Okay. Today we're going to start with long division. Okay, which is a way to factor polynomials. Okay, then I'll show you the easy way to do it using synthetic division. And then we'll talk about the remainder theorem. And that'll be it. So, long division. Okay, we did do this last year. So I hope that it's review. It might come back to you. Okay. So notice the words that I used here to ask you to break this down. Okay, so factoring is simply simply dividing. Okay, so we're going to use long division to factor this cubic polynomial out. Okay, so we're going to start by just setting up the long division. You guys remember long division? I wonder if they teach long division in elementary school anymore.
Probably not, though.
They've changed things a lot.
I was babysitting fourth graders last year, and I didn't do their math homework.
It's hard.
Yeah.
Well, it's just you have to use your other side of the brain to do it.
I'm like, how did your teacher say to do this? I'm like, I don't know. My brother did that. It's great. Like, I can't remember this word.
It is a lot different. It's a lot different. Okay. So the way I start long division is I start by looking at the first term of both the divisor and the dividend. Okay, so I'm comparing the x to the 6x cubed and saying to myself, what do I have to multiply x by to make it 6x cubed? 6x squared. Okay, so when I say 6x squared, I'm going to put that on the top, and I'm going to make sure I line all of my variables up. So if I said x squared, I want to line it up above the x squared piece, so everything is above itself. Okay, so then once I put the number on the top, I'm going to multiply that through my divisor, the x minus 3 piece. Okay, so what is 6x squared times x? 6x cubed. And what is 6x squared times negative 3? Negative 18x squared. Okay, so then I do this. Does anybody remember what I do now? Then you subtract. Good. Okay, so when I subtract, my first term, those x cubes, should go away if I've done this correctly. Okay, then I go to my x squared. What's negative 25 minus negative 18x squared? Negative 7. Okay, and I will tell you, when people make mistakes on long division, it is when they subtract. It is a killer. Be careful of those double negatives. Okay, so once I subtract, I'm going to bring down the next term. So I'm going to say then plus 18x. Okay, and at this point, I'm going to start that little process again. I'm going to look at the x of the divisor and compare it to negative 7x squared. Okay, so what would you have to multiply x by to make it negative 7x squared? Negative 7x. So I'm going to go negative 7x on the top, and then I'm going to multiply that through. So it's negative 7x times x. Negative 7x. What's negative 7x times negative 3? 21x. Good. Okay, then I'm going to subtract. Okay, if I subtract, the x squared should go away, which they do. How many x's do I have? What is 18 minus 21? Negative 3. So I get negative 3x, and I'm going to pull the next term. Okay, so I do it again. I'm looking at the divisor x, comparing it to negative 3x. What do I have to multiply x by to make it negative 3x? Negative 3. So negative 3 goes up top, and I multiply it through. So it's negative 3 times x. And what's negative 3 times negative 3? Positive 9. Okay, when I subtract, my x's go away. What's 9 minus 9? What did I just find? What's that 0? The remainder. Very good. Okay, so now here is a really, really important part of this. The only time you ever completely factor, or factor for that matter, is if you get a remainder of 0. Okay, if you end up getting a remainder of any other number, then it is not a factor of the quantity that you just divided. Everybody got that? Okay, so if I have 6x squared minus 7x minus 3, is that completely factored?
Yes.
Okay, so completely factored means all of the terms are linear. Factor. Special kind of factoring. How do I factor that?
So then we have to factor that.
Yeah, then you have to factor that.
Jeez.
So how do I factor that? You gotta do hard method, right? You guys remember hard method? Gosh, it's a good day to do hard method. So you multiply the first times the last, so it's 6 times negative 3. What two numbers multiply to negative 18 and add to negative 7? Negative 9 and positive 2. So you go 6x squared minus 9x plus 2x minus 3. Okay, you got to rewrite it. Then you group the first two, group the last two. Pull out the greatest common factor. So what's the greatest common factor of the first quantity? 3x. What's left over if I pull a 3x out of both those terms? Minus 3. And then what's the greatest common factor of the second quantity? What's left over? Okay, so what are my two quantities for this particular piece? 3x plus 1, 2x minus 3. Okay, so notice, I just factored 6x squared minus 7x. That's the factored version of that. Remember my original statement was completely factor this one up here. So what's the one quantity I need to include in my final answer? X minus 3, because x minus 3 is a factor. So I'm going to say x minus 3 at the end here. Whoa. Grace, are you following along with us? Because I hear a lot of chatterbox.
I actually have all the notes so far.
Do I need to do another example of this? One more? One more. Sorry. Okay, so let's do x cubed plus 7x squared plus 4x minus 12, and we're going to completely factor using x plus 3 as a factor. Okay? So I set it up. X plus 6. Whoops. Yep. That's what I didn't say, but wrote correctly for once.
I was just asking.
Write it. Good point. It's best to ask. All right, ready? Here we go. Okay, so I'm looking at the first term of each of these. What do I have to multiply x by to make it x cubed? X squared, so I'm going to line that up, x squared, and then I multiply it through. X squared times x is x cubed. X squared times 6 is 6x squared. Then I subtract. My x cubes go away. How many x squareds do I have? 1x squared. I'm going to drop the next term, which is the 4x. See there? Moving on, if I compare the x to the x squared, what do I have to multiply x by to make it x squared? X. So I take x and I multiply it through, so I have x times x, which is x squared, and I have x times 6, which makes 6 x's, and then I subtract. So when I subtract, the x squareds go away, and my linear term becomes 4 minus 6 is negative 2x. So then I drop the next term, so I have a minus 12 at the end of this, and I get to play one more time. What do I have to multiply x by to make a negative 2x? Negative 2. So when I send that through, I have negative 2 times x, which makes negative 2x. I have negative 2 times positive 6, which makes negative 12. And if I subtract, what is my remainder? 0. Okay, so did I correctly factor this? Is x squared plus x minus 2 a actual factor of our original polynomial? Absolutely, because of the remainder of 0. So I'm going to take my x squared plus x minus 2 and completely factor it. Oh, I like this easy method on this one. What two numbers multiply to negative 2 and add to positive 1? X plus 2, x minus 1, and then I have to include my original quantity, which was x plus 6. And that is completely factored. If you didn't believe me, you could FOIL that all out and you should get the original polynomial. Perfect. Okay. They're also going to ask you to just simply divide polynomials. I don't want to go through this whole thing. Do you guys remember how to write remainders if you don't get a remainder of 0? No. Okay, so example number 3. That's so disappointing that they did that. Like, what does that even mean? Alright, so this particular question, if they ask me to divide it, I must use long division. Do you guys remember the difference between when you can use long division and when you can use synthetic division? Well, it has to be a linear quantity. So we could have technically used synthetic division in the first two because they were linear quantities. But when you divide, your divisor is not a linear, like x plus 5 or x minus 3 or whatever. You have to use long division. So let's do this super fast. This is another long division, but I just want to go over how you write remainders. So I'll do this fast, if that's okay with you guys. Okay, so to get from x squared to 2x to the 4th, I would need 2x squared. Multiply that through. 2x squared times x squared is 2x to the 4th. 2x squared times negative 2x is negative 4x cubed. 2x squared times 7 is 14x squared. Oops, sorry, I missed a term there. If I subtract, that goes away. That goes away. And I'm left with negative x squared. Drop the plus 3x. And because on this particular question, since my divisor has 3 terms, my next piece needs to have 3 terms. So that means I have to drop both of these so that they're the same amount of terms going through. Okay. So then I play again. So what do you have to multiply x squared by to make a negative x squared? Negative 1, right? So I'm going to put that over here, negative 1. So then I multiply that through. Negative 1 times x squared is negative x squared. Negative 1 times negative 2x is positive 2x. Negative 1 times 7 is negative 7. And then I subtract. Okay, when I subtract, my x squareds go. How many x's do I get? 1x. How many constants? -4. Okay, so at this point, I know that I'm finished because the first term on my divisor is bigger than what's underneath. I couldn't multiply x squared by something to get something smaller. Okay, so at this point, this is my remainder. So to write the remainder, so my answer would be 2x squared minus 1 plus x minus 4 over the divisor. Okay, so all you do is you simply add the remainder over the divisor. Everybody good with that? Check. Okay. All right, so synthetic. Here we go. Now it gets fun.
Yes.
Okay, so I'm going to make a blanket statement in using synthetic division. Okay, if they say use long division, you got to use long division. Okay, it's good practice. Okay, but if they don't say specifically what kind of division that they want you to use and you can use it, as long as that divisor is linear, then you can always use synthetic. Okay, so divide, what are we on, example 4 maybe? So 2x to the 4th minus 5x squared plus 5x minus 2 divided by x plus 2. Oh, that didn't work. Okay, so remember that this has to be linear. Must be linear. Okay, so what do I put in the corner? -2. Okay, so you take the quantity and you set it equal to 0. That's the value that goes into the box. Okay, then I'm going to pull the numbers that are in front of each term. Make sure that you have a placeholder for every single term. If there's a term that's missing, you need a 0. Okay, so how many x to the 4th do I have?
2.
How many x cubes do I have? 0. How many x squareds? -5. How many linears? How many constants? -2. Okay, so then I leave a space. Okay, so I start by just simply pulling the first number down. So I'm going to pull the 2, and then what do I do? Good, so you multiply by the box. So it's 2 times -2, -4. And then I'm going to go straight down. You guys remember what I do with synthetic? No, you add. Okay, synthetic division, you add. Okay, so don't forget, long division you subtract, synthetic you add. Okay, so it's 0 plus -4. Okay, then I multiply, and I just keep going all the way through the same step. So it's -4 times -2, 8. -5 plus 8, 3 times -2, 5 plus -6, -1 times -2, -2 plus 2.
0.
Now I always put this last number into the box. Why do I do that? It's the remainder. Remainder. Okay, so if I'm just asked to divide this polynomial, I can't just leave it like that. I need to write it as a polynomial. So what's my polynomial? 2x what? To the 3rd, because I just lose one exponent from the original. Minus 4x squared plus 3x minus 1. And if I did have a value for a remainder, I would say plus, let's just say it was 8, for example. I would say plus 8 over my divisor of x plus 2. Okay. Do not use r. I will come and beat you. Stick. Do I need to do another example of that? You want another example of synthetic? Let me use it with remainder theorem. How about that? I think this is such a cool theorem. I never ever use it, but it's cool. I never remember to use it anyways. Okay, so the remainder theorem is simply a technique that is used to find the function value at a given x. Okay, so if I'm given some function and they ask me to find the value of the function when the x value is 5, I can use the remainder theorem. Okay, normally if you saw something like this, you probably would say, oh, I just take 5 and I plug it into the function and then I just simplify. Okay, which is totally right, but you can also use the remainder theorem. Okay, so to use the remainder theorem, what number am I going to put into the box? 5. Okay, so you use the number that they give to you on the remainder theorem. So that's one little piece that kind of gets confusing. You use what's given to you on the remainder theorem. Okay, what are the numbers that follow here? 1, -12, 4, 10. Okay, so I do my synthetic division. Okay, so I drop the 1. 1 times 5 is 5. What's -12 plus 5? -7 times 5? 4 plus -35? -31 times 5? And 10 plus -155. Okay, so the cool thing about this is the function value at 5 is simply the remainder. Okay, so it is -145. That's pretty cool, right? Whoever thought of that? Genius.
I know, I was just thinking about that one. Who came up with that? Somebody really smart.
Mr. Remainder. I don't know. Alright, so that's all I have for notes.